factors which affect the strength of the magnetic effect by current. So on what factors it depends? The magnetic effect will depend upon the number of turns which you are giving for that particular whatever material you are taking. Suppose I took one rod like this, and around it I wounded copper wire like this. And when I wounded copper wire like this, what happens? That copper wire, whenever wounded, and if electricity passes through it, then magnetic field can be created, and that magnetic field which is created will depend upon this number of turns. Whatever turns are there, so number of turns it will depend. Next, magnetic effect will depend upon the value of current. If current increases, magnetic effect also increases. If number of turns are increasing, magnetic effect also will increase. And next one, this magnetic effect will depend upon the nature of the core which is there inside of the coil. That means if you take copper wire, it will create more magnetic field. If you take iron rod, it will create less magnetic effect. Like that, it will depend upon the material which we are using. So in this way, the magnetic field which is produced by electric current will depend upon the three terms. One is number of turns of that particular coil which we are taking. Coil means what? Which is wounded like this. I drawn one diagram now, wounded one. Maybe you know that in your fan, if you open it, some coil will be there. Have you seen coil? Inside that copper wire will be wounded for many number of times. Have you seen it? Priscilla?
No, sir, I didn't see a coil.
You have not seen coil. And it will be there in our in our bike also it will be there. Wherever Bhavya Kriti?
Sir, I have seen coil.
Okay. So for a coil, number of turns will be there or not? Copper wire coil.
Yes, sir.
Right. If number of turns are increased, magnetic field will be increased.
Magnetic field will also increase.
Very good. So if current is increased in it, magnetic field also will increase.
Magnetic field will increase.
Okay. So if we use copper wire, more magnetic field will be created. If we use iron material, that will create less magnetic field. So in this way, magnetic effect will depend upon three terms like this. So next, applications of heating and magnetic effect of electric current. So for heating, electric fuse will be there. MCB means miniature
something is there.
breaker will be there. It will be right. It will be there in our next slide. We will go through it. And next one is electromagnet, and after that electric belt. And let us observe all these applications. And these are the applications of heating and magnetic effect both. So in electric fuse only heating effect will be there, and in a MCB also heating effect will be there. In electromagnet and electric bell, magnetic effect will be there. So let us discuss about them in brief. Next one is electric fuse.
MCB means miniature circuit breaker.
Miniature circuit breaker, that will be there. Next slide. Next slide, that only will be there. But first, let us learn about electric fuse. Have you seen this type of electric fuse at your home?
Sir, I saw the sir in this picture, the third one. It is there in the inverter.
Right, it will be there in your inverter. Very good. And have you seen for your home, second one will be there, fuse in buildings?
Yes, sir, I have seen, sir.
In every room it will be there nowadays. In every room, or definitely wherever main is there, current main will be there, no? That meter will be there or not?
Sir.
Wherever meter is there, what will be there at that particular place? Electric fuse will be there.
Electrical, what is it? Fuse.
Fuse will be there. Okay. Have you seen, Priscilla, this electric fuse?
Sir, the last one I saw, sir.
Last one use in that is used in inverters.
Yes, sir.
The second one you have not seen.
No,
Sir,
sir.
I've seen all of these, sir. I've seen, except for the first one, I've seen the second and the third.
Okay. So generally second and third will be there and at least after completing this class you ask your parents wherever main is there, their electric fuse is there or not, once you show it. So you ask like that, and in that electric fuse like this will be there. And what is the electric fuse? The electric fuse is a device which is used in an electrical circuit, and it is used for what? Protecting the electrical devices against the overload or short circuit. So overload means whenever high current comes, large amount of current reaches to your home. Generally what happens is the TV appliances will be spoiled, like TVs, refrigerator, and even sometimes bulbs will be exploded if you get more current actually.
Sir,
Have you
geyser.
ever observed? Geysers also, those also will be spoiled. So wherever suppose required current is 5 ampere, and if you are getting 10 amperes of current, it is more than 5 ampere or not? And when more
Yes.
than 5 ampere you are getting, then what happens is that particular device will be spoiled or it will be damaged. And sometimes you can see if more current passes through TVs, that will be exploded like anything, right? So to protect such kind of a events, to protect from such kind of events, what we use, electrical fuse will be used, and it will be there near to our main only. Why it will be there near to our main? Whenever current reaches into our home, it reaches from the main, and when from main to reach our home, first it has to pass through the what? Electrical fuse, and after that it reaches to our home. Suppose if more current comes, then what electrical fuse, what will happen to the electrical fuse? That electrical fuse will be burnt. And when electrical fuse is burnt, that will be melted. And when that electrical fuse is melted, what happens? Circuit will be become open. And whenever circuit is open,
Sir, the circuit
already
is stopped.
circuit is stopped. When circuit is stopped, current will be flowing through our all other devices, or it will be stopped.
It will be stopped.
Stopped.
Very good. It will be stopped. When it stops, that means your whatever devices are there, those are protected or not?
Yes.
Yes,
So
sir.
those are protected. So to protect it, that electrical fuse must melt whenever overcurrent is coming or not? It
Yes,
has
sir.
to, it has to melt quickly or not whenever more current is coming.
Yes.
Right. It has to melt. And to melt, what must be there? High heat energy must be there, isn't
Yes.
it? So to have a high heat energy, the material which we are using as a fuse, electrical fuse, must have high resistance or low resistance.
High resistance.
Right. So this is electrical fuse wire actually. So here also it is given. This is electrical fuse wire, right? And this fuse wire must have large resistance. High resistance must be there. Why high resistance?
So that it can produce more heat and it will melt.
Very good. To produce more heat energy, and when produces more heat energy, it can melt. So
It
to
can.
melt easily, what must be there for it? One more parameter. Tell me, what must be there to melt easily?
It must be a metal.
It must be a metal. Which type of metal? The metal which is having low melting point. Do you know what is a melting point?
Yes, sir.
Tell me
Where
what.
the metal changes from solid state to liquid state.
Melting means becoming solid as a liquid, isn't it?
Yes.
Huh? Arna?
High low melting point.
Low melting point must be there. That means at a very small
If it's
temperature.
high melting, it would melt easily and faster, right?
Tell me again, Arna.
So, but if, so you told that low melting metal should be there, but
Okay.
if you have a high melting metal, won't it be faster?
If high melting point is there, definitely circuit will not break. When circuit is not broken, what happens? Current reaches to your home and it will reach to your appliances. Overcurrent also will reach to your appliances, and thereby what happens? Those whatever
Let's stop working.
devices are there, those will be get damaged, isn't it?
So that's why
So
you
that's
need a low melting
so
metal.
that's why low melting point must be there. Low melting means at very small temperatures only it must melt. That means solid must be converted into liquid. So very quickly it must melt. So that's why low melting point must be there. And apart from that, this particular fuse wire must be very thin. And if it is very thick, what happens? It will not melt that much easily. But if you take thin wire, then what happens? It will melt easily and circuit will break. Circuit will break. So thereby your devices will be protected. So that means whatever the electric fuse wire you are taking, that fuse wire must have three parameters. Three characteristics must be there for it. What those three characteristics are? First one, it must have high resistance. Second one, it must have low melting point. And the third one, it must be a thin wire. Is it clear? Is it
Yes,
clear?
sir.
Right. Arna, is it clear?
Yes, sir.
Right. Priscilla?
Yes, sir.
Okay. Now let us move to the next one. MCB. Nowadays, we are using
Sir,
miniature circuit breakers. Okay, tell me, Priscilla.
sir, like what metal do we use for electric fuse?
Generally, whatever thin wires are there, like nickel wire will be there, and even copper wire also we can use. Very thin copper wire also we can use. And do you know some small electrical wires will be there in our home? Electrical wires. Have you seen electrical wire? Plastic coated will be there over it.
No, sir.
Not seen. Okay. Copper thin wire or nickel thin wire and iron thin wire also you can take. But generally we use copper. Copper will melt very easily. So that's why we use copper also. So those type of a fuse wires will be used. But it must have those characteristics. Which type of characteristics? High resistance, low melting point, and it must be very thin. Okay. Right. And instead of these electric fuses, nowadays we are using miniature circuit breakers. And maybe nowadays if you construct the home, definitely these type of breakers will be there. Have you seen that type of breakers which are there in your slide? Anyone seen this type of a miniature circuit breakers? Bhavyakriti,
No, sir.
Sir, I've seen, sir. They've put these MCBs only in our house.
where?
Sir, in my house, they put these MCBs only.
Okay.
In the main, what do you say, main fuse kind of thingy. They put
Right.
these only.
Wherever a room will be there, so in that room some controls will be there. And at that control, this miniature circuit breakers will be kept. And nowadays, these MCBs are used more in number. And when you are using MCB breakers, what happens is, if you are getting high current in one room, then that breaker only will be automatically switched off. And if
Okay.
you are getting high current in
Yes,
other
sir.
room, then
Yes, sir.
that MCB will be closed.
Yes,
So
sir.
like that.
Like if there is a high current flowing through any of it, or high current, like very much current used in any of the room, that like the that main switch, it will get switched off.
Very good.
It will
So
come
generally
down with
what
the
happens
high.
is If over current, that means higher current comes, which exceeds the limit of it, then what happens is automatically this breaker will be turned off. And when this breaker is turned off, what happens? Circuit will become open. When circuit becomes open, definitely that particular current will not flow through the all devices, and thereby devices will be protected. So this is what we are using nowadays. Okay, and this MCB is replacing what? Electrical fuse. So these are heating effect or magnetic effect. Whatever devices, two devices you learned, these are related with the heating effect. Now we are learning about magnetic effect. And to learn about magnetic effect, first you have to understand about electromagnet. And to understand about electromagnet, now one diagram is given in your slide. One cell is there and it is connected to the copper wire, which is wounded to what? Iron nail. Okay. Now, if electricity passes through the cell, tell me what happens to the iron nail? Priscilla, if
Can you
electricity
repeat?
passes through the passes through the connecting wire, which is wounded to the iron nail, what happens to the iron nail?
Becomes an
Tell me, Unmana.
electromagnet.
Unmana, tell me.
Unmana, can
Unmana.
you mute?
Unmana.
So current flows through it.
Current flows through it. What iron nail will behave as?
Sir, so can
Okay,
I tell?
Bhavya.
Yes, sir. Sir, the iron nail, it will act as a conductor.
It will act as a conductor. Iron is a bit of a conductor. Copper wire is also a bit of conductor. So current
Yes, sir.
flows through the iron nail. When current
Yes,
flows through the iron nail or through that copper wire which is wounded to it, then what happens is that iron nail will behave like a magnet.
Yes, sir.
It will behave like a
It will get magnetized.
it will be get magnetized. That means magnetic properties will be created in that iron nail.
Yes,
And
sir.
when magnetic properties are created in that iron nail, then if you keep any iron rod or any other magnetic material like nickel, cobalt, all these materials, if you are keeping close to that iron nail, what happens? That iron nail will attract them. Why it will attract them? Because iron nail will act like a magnet due to the presence of what? Electricity. And suppose if that electric cell is removed from that circuit, then what happens?
Sir, the electricity will not be conducted.
Electricity will not pass through it. When electricity not passes through that particular conductor, then what iron nail will behave like a?
Insulator.
It will behave like an insulator. What, Unmana, tell me? You tell me now. Unmana.
Yes, sir.
Tell me. If current flows through the copper wire which is wounded to the iron nail will behave like a magnet. If electric cell is removed from the circuit, whether current passes through it or not.
No.
No. If current is not passing through it, now iron nail will behave like a magnet or not?
No.
No. That means whatever magnetic properties are there whenever current is flowing, that will be lost by iron nail when electricity is switched off. That means
Yes.
whenever electricity is there, then only it will behave like a magnet. When electricity is not there, it will not behave like a magnet. That means electromagnet is a permanent magnet or temporary magnet? Electromagnet is
Temporary.
very good. Electromagnet is always temporary magnet. Temporary means what? Temporary
So
means
it
what?
lasts only for some time.
Very good. So it behave like a magnet for some time only. After that, it will not behave like a magnet. So temporary magnet. Electromagnets are always temporary magnets. As long as electricity passes, then only it will behave like a magnet. If electricity is switched off,
Sir, your voice is breaking.
again, if electricity is passing through it, then it will behave like a magnet. Now, is it clear, Bhavyakriti?
Yes, sir. Now it's clear.
Okay. So, if electricity passes through it, it will behave like a magnet. If electricity stopped by it, then it will not behave like a magnet. That is called electromagnet. So, electromagnet is a temporary magnet. It is not a permanent magnet. And
Yes,
generally,
sir.
where we use this particular electromagnet, that electromagnet will be used in a electrical bell.
Sir,
Observe
not
carefully.
only an electrical bell, sir. Speakers. It will be in
Very good.
speakers.
It will be used in speakers. It will be used in some kind of a machines also.
Yes, sir. In missions, they use it.
Okay. Right. Now, once you observe your slide, in that slide,
Sir,
which picture is there? Okay, tell me.
sir,
Priscilla.
it will also be used in cranes which remove the scrap.
Very good. Very good. There also we use electromagnet will be used to remove the scrap also. And to remove the scrap, that means iron materials, whatever are there from it, that can be removed. When electricity passes through, it will behave like a magnet and it will attract it. And after that, taking that to specified place, and after that, electricity will be switched off, and those iron whatever materials are there, those will be dropped. So in that crane also, to remove that iron like substances, we use it. Okay, very good. Now observe carefully the diagram, electric bell, and in that electric bell, if you observe it, now observe here clearly. Now this is a coil. Now just now I said no, this is coil. Have you seen this type of things, Priscilla?
Yes, sir.
So this is only coil, and in that copper wire is there or not, wounded one, rounds.
Yes, sir.
If number of turns are increasing, magnetic property will
More
be
magnetic properties.
very good, like that. So two coils are used here, and when electricity passes through it, it will behave like a magnet. And when it is behaving like a magnet, what happens is, now this particular whatever two coils are there, these two coils whatever are there here, two coils are there, no? So these two coils are connected to this bell, and when current is passing through it, this bell will act like a magnet, and when it is acting like a magnet, here magnetic material is there, this magnetic material will be attracted, and when magnetic material is attracted, here it comes and touches it. When it touches it, what happens? Sound will be produced.
The sound will come.
Sound will come. That means it will be used to produce the sound by which method? Electromagnet method. That means here electromagnetic effect can be used to produce the sound like this, and this will be called electric bell. Okay, is it clear?
Yes, sir.
Arna, is it clear?
Yes, sir, can you repeat again?
Right. Now here two coils are there. No, Arna, see, two
Yes,
coils
sir.
are there. If current flows through it, they will behave like a magnet. But this current will be connected to this one. This big one is there, no, big jar like this is there, no. So it will be connected to this. When it is connected to this, if current is flowing it through it, then what happens is it will behave like a magnet. When it behaves like a magnet, definitely it will attract the magnetic materials. So one magnetic material will be placed close to it, and that magnetic material will be attracted by this one. And when magnetic material is attracted by it, it comes and hits this. And when it hits this, what happens? It will produce the sound. So in this way, electrical bell will work. Is it clear or not?
Yes, sir.